Hey everybody, this is section 1.5. So we do 3 sections out of chapter 1 right here, right now, in a strange spot in the middle of the semester. Um, Partially it's because it does us more good going into chapter 8. Really, it's where Bucks decides to put it, and this is the life we're going to lead. You'll be happy to see it probably. So the first section in here is about compound inequalities. What you need to know about them is really that there's 2 ways to think about compound inequalities, or 2 kinds of things that happen really. There's one case where I'm trying to figure out A or B. I thought I grabbed my pen once again, and I didn't. Sorry. A or B, the union of sets. It means that whatever I'm figuring out as my answer is okay into being 2 sets. It's a part of both. Like I describe it in one of my other classes, or is sort of like, I promise you tomorrow when you come home, there's either going to be a tiger or a monkey. You're happy if you get either one. But if there's none, you're like, what the heck, man? The intersection of 2 sets, A and B, this is the symbol for and, the one up here is the one for or, means it's just things in common. So if I tell you there's going to be a tiger and a monkey tomorrow, and you come home and I only have one of them, you're disappointed. Either way. Or if I have none of them, you're still disappointed. There's a smaller subset in there. It's only exactly what I promised, both things at the same time. This applies to lots of different things, but we're going to start with finding unions and intersections of sets. This is an or. So if I want to think about the things that are in set A or set B, I include everything that's in either set, but I only have to write them once. So they both have an A, I'm going to write A. Set A has a B, they both have a C. A has a D. Set B has E. Set A has F, G, and B. There's no H, I, and K. So when it's or, it's whatever they share, all of it. Okay, the things that they overlap as well as the things they don't. In and, when I'm looking at A and B, I only want the things they have in common. So they both have an A, they both have a C, they both have an E, but that's it. So and in this case, and in most cases, is a significantly smaller set, okay? Because it really is just the overlapping parts. This is find the intersection, the and, for A and C. And what you look at and see, let's see, they don't share A, B, C, D, E, F, nope, G, H, I, J, K. There is no intersection. There's nothing in that set. So there's a couple of ways to write that. One of them is that. That's option number 1. Option number 2 is to write empty brackets. What it never is both of those at the same time. Okay, so choice number 1, choice number 2, pick one. That's how you explain when there's nothing in a set. All right, I think you can do this. You go ahead and try these. If you have questions about it, drop into the discussion. You know what to do. And oh gosh, sorry. Let's use the sets a little differently. So in A, these get a little overlapping. For whatever reason, the type is really big, X, where X is less than 3. B is X where X is greater than or equal to -2. And we see C. So the way this is read, okay, this is set A. Sets are always capital letters. And it's about X where, that's what this bar says, X is less than -3. So inside of set A, I basically have, or +3, all of the things that are less than 3, okay? In set B, I have X where X is greater than or equal to -2. So in set B, I have all of the things that are going from -2 up. And ... means it continues. And then set C is X where X is greater than or equal to 5. Okay, so 5, 6, 7, and so on. Now we have to graph each set and express it in interval notation. All right, so let's start with A. This is A and B. So now we have to think about it. We have to think about what the picture would be. Whenever this says graph in this section, and in chapter 1 things, we're talking about graphing on a number line. So I'm going to put some numbers here. So let's see. Oops, +1, -1, +2, -2, 3, -3. All right, A is x's less than 3. So I'm going to do A in green. X is less than 3. Less than means 3 is not included, gets an open circle. And I'm going to color in the direction of less than. I'll do set B in purple. B is x is greater than or equal to -2. So when it's less than and equal to or greater than or equal to, colored in circle. When it's less than or greater than, open circle. Okay, so at -2, I'm going to color in my spot. And then I'm going greater than. So I'm going the other direction. What I want in this case is the overlap. So my set for the overlap is from -2, -1, 0, 1, 2. That's it. That's it in set notation. I could also write it as -2 less than or equal to x less than 3. Okay. Either way, you're not always going to be able to do this way because sometimes there's too much stuff. Let's try another. This is the same A. A is where x is less than 3. B is where x is greater than -2. We can see 5. So I'm going to do A or C. So I'm going to start once again with a number line. I'm going to put them both on there. So 0, 1, 2, 3, 4, 5, -1, -2. A, I'm going to do in red. A is maybe where x is less than 3. So again, open circle, color to your left. C is where, I'll do that in blue. C is where x is greater than or equal to 5. So colored in circle over this way. Or means both things are okay. So what I have to use is both. There is a handy way to do this if this is not familiar to you. So to cover A, it really continues on and on and on all the way down here. That's going to go all the way to -infinity. Okay, then at 3, it's not included. So it's a soft bracket. Okay, then I join them this same way, or, okay, from -5, or sorry, +5. And it gets a hard bracket like this. That means it's included to +infinity because that will just keep going on. Okay, you're going to do a bunch of these. Let's try another. A is greater than -1. X is greater where x is greater than or equal to -1. B is x where x is less than 4, and C is x where x is greater than 9. So A and B. So this is number 4. Let's graph A and B. So I need my number line. That's 4, that's -1. I'm going to do A first in green. It's greater than or equal to -1, so I can color in and go up. It's going to keep going forever. B I'll do in blue. X where x is less than 4. So open circle, not included. And is the overlap. So I'm going to go from -1. It's included. Oops, sorry, that should be x, not 0. I was looking at 0 and I wrote 0. All the way up to 4. Let's try 5. So it's B or C. So B, 1, 2, 3, 4, 9. Let's do B in blue, red this time. So x is less than 4. Goes that way with an open circle. We just did that. x is greater than or equal to 9. Let's do that in purple. Greater than or closed circle equal to 9. So this one they don't connect, but as long as it's or, they're fine. So I need 2 buckets here. From negative infinity to 4. 4 is not included, so soft parentheses. So that should be a soft parenthesis too. Or, oh, sorry, my pen is not keeping up with my fingers. Or hard bracket, because the 9 is included, up to infinity. All right. Okay, let's try something else. I want to find the union or intersection as indicated. So what I'm going to do is I'm going to draw both, and then I'm going to see what's asked for. So this is from negative infinity to 2. Start with the number line, negative 2. So from negative 2 to negative infinity. Soft bracket means it's not included. That's what that looks like. This guy goes from negative 4. Hard bracket means he's included, all the way up to 1, 2, 3. So this is an or. So now I have to look at the range from this end all the way to here. So when it's or like this, everything's included. There's no break, so I don't need an or symbol. I can just talk continuously from one end to the other. So, it should be open circle here. I'm going from negative infinity on the left all the way up to 3. 3 is included, or sorry, not included. Let's see how this one works. This is an and. So it's the same picture basically, right? From negative 2 to negative infinity, negative 2 not included. From negative 4 included to 3. What I want in this case for and is this little tiny bit of overlap. So the overlap goes from, hard bracket at negative 4 all the way up to negative 2. And that's it. There's only a tiny little bit of overlap there. All right. You can try these. You can do them. When you do the first one, it should go from negative infinity to 0. The second one should go from negative 7 to negative 5. Okay. All right. Some information. So sometimes we have to actually solve compounding inequalities. We solve them and graph them separately. If it's joined by the and word, the word and, we find the intersections, the crossover. If it's not, we write it as an or. Express your answer in set notation is typical. So in and, what I'm going to do is I'm going to solve each of them. So this gets me x is greater. Remember when you divide by a negative and it's an inequality sign, we flip the sign. So I get x is greater than negative 3. I get x is less than or equal to 2. So now I'm going to graph each one. I'll do the first one in red. X is greater than negative 3, so open circle to the right. X is less than negative 2, or sorry, positive 2. Oof, my brain. Included this way. This is an and, so what I want is the overlap. I'm going from negative 3, which is not included, up to 2, which is. All right. Turn my page so I can see my notes. This works the same way. You can do this. These are just two-step equations. When you get to the end of this here, you should get a hard bracket at negative 2 all the way up to 6. All right, so we're going to skip a couple here. We're going to go to this one. This one works the same way. It just has a scary fraction. Don't be scared. Okay, what we do to solve this is multiply both sides by the reciprocal. The fractions drop away. We multiplied by a negative, our sign has to flip. Okay, so it's going to be a negative answer. Negative 3 times 6 is negative 18 divided by 2 is negative 9. All right, on the other side, I'm going to do the same thing. I'm going to multiply by a negative half. to both, or sorry, not negative half, negative reciprocal. Wait, negative 2 over 1. That's going to drop these fractions away. X is going to be greater than negative 2. So now we graph. All right, so I have negative 2 and negative 9. I'm going to draw myself some room this way. So 1, negative 2, 3, 4, 5, 6, 7, 8, negative 9. So the first graph is from negative x is greater than or equal to negative 9, so included to the right. The second one is x is greater than negative 2, not included, still to the right. This is an and, so I want the overlap. The only way it overlaps is starting at negative 2, moving to the right. So negative 2 is not included, but it keeps going on to infinity. Okay? You try that one, works same way. All right, this one looks a little different, right? It's the same idea though. So when an inequality is written this way, what we do is just solve in two directions. The first step, if you covered up where the negative 4 was, you just use your hand, cover it up. Just looks like 3x plus 5 is less than or equal to 10. You know how to solve that. If you then took the same hand and covered up where less than or equal to 10 is, you could solve negative 4 is less than 3x plus 5. The first thing you would do in either case is subtract 5. We can just do that in both directions. So I get negative 5 less than 3x less than or equal to 5. Remember, you only flip the sign when you're multiplying or dividing by a negative, not when you're adding or subtracting. So then I would divide everything by 3. I get negative 3 less than x less than or equal to 5/3. It's done. Then we graph every time, okay? So I have 0, I have negative 3, I have 5/3 is almost 2, right? So up there, I have an open circle at negative 3, I have a closed circle at 5/3. It's in between, okay? I would write that as negative 3, 5/3. Not terrible. Here's the next one. I can't turn the page. So what we would do here is exactly the same thing. You try this one. When you're finished, you should get, let's see, hard bracket at -1/2 to 3, soft bracket. Okay, try the graph, try the process. This one looks a little different, right? It's not that bad. If you just cover up one side, you say to yourself, okay, so how do I get that 3 out of the denominator? Well, I would multiply both sides by its reciprocal. So it's multiply both sides by -3. I'm going to multiply both sides. That's going to cancel out. I'm going to get -6. I multiplied by a negative, so I'm going to flip the signs. P minus 2, 3. Okay. Now I'm going to add 2 to both sides. Every direction. So I get -4 less than or equal to P less than or equal to 5. Okay. The world didn't end. I can make a graph of that. From -4 to 5, both are colored in. And then I can write that in interval notation. Done. Okay. You can try the next one. When you're finished with this one, it works just like the last one. The answer should be from -20 to +6. Okay, soft brackets. When you solve a compound inequality with or, so what we just did was and, we wanted the overlap. You do the same thing we've done. Solve them each separately. If they're joined by or, we find the, not the overlap, but everything included, the union, and we write it in set notation. Excuse me. Okay, so just like we did last time, solve one of them. I get -3y greater than 9, divide by -3, divide by -3. Y is less than -3. Okay, on this one, subtract 4. I get negative y less than or equal to 2. Divide by negative 1. I get y greater than or equal to negative 2. All right. So I'm going to put them on the number line. I got negative 3, negative 2. When it's or, it's okay if there's no overlap. This is y is less than negative 3, and y is greater than or equal to, so close circle, negative 2. We just write them how they look. When they have a break like that, you write a union. So from negative 3 to negative infinity, and from negative 2 to positive infinity. That's it. You try this one. Again, works exactly the same way. When you're finished, it should be negative infinity to negative 2, negative 2 is included, or from 3 to infinity. Okay. All right, couple more. This is another or. In this case, excuse me, I have a little bit of fall allergies trying to get me here. I'm going to solve just like I've been. Minus 3. 4x is less than, what's that? 13. Divide by 4. Divide by 4. X is less than 13 over 4. It's okay to leave it like that. Divide by negative 2. X is greater than negative 3 halves. All right. So draw your picture. So I'm going to go from negative 3 halves to 13 over 4, give or take. At 13 over 4, it's not included, and we're going this way. At negative 3 halves, it's not included, and we're going this way. Now remember, we're not looking at the overlap, we're looking at what's covered. In this case, everything's covered because the blue line is going to continue forever to the right. The red line is going to continue forever to the left. So what it's going to be is from negative infinity to positive infinity. That's all you need. All right, this one you can try, but works out the same way. Worth the effort though, so please try it. And then let's see what we're doing next. Oh, here's some translating, some putting what we're doing into words, putting what we're doing into symbols, okay? So the normal level of thyroid stimulating hormone, THS, for adults ranges from 0.4 to 4.8 microunits per milliliter, inclusive. It means both ends are included. This means when you see that word, you should be thinking about these symbols. Let X represent the amount of TSH measured in microunits per milliliter. Write an inequality representing the normal range. Well, it goes from 0.4 inclusive to 4.8, right? That's what they're saying. This is the range. This is how you write it as an inequality. Same issue, same question. Write a compound inequality representing abnormal. So normal was from 0.4 to 4.8. What's abnormal? Well, it's everything over here on the left past 0.4 and then on the right past 4.8. So I'm going to need 2 buckets here. So I need a union. So it goes up to 0.4, but doesn't include it because it's already included in the normal from negative infinity. Then, it goes down from negative 0.4. It also goes up, not including 4.8, but up from it to infinity. Okay. All right, you try this one. And then there's one more. So this is a problem that says the sum of a number and 4 is between negative 5 and 12. Find the numbers. So think about what it says. It says the sum of a number and 4. Well, I would write that as x plus 4. The sum of a number and 4 is between 5 and 12. So it's greater, sorry, my pen. It's greater than negative 5, and it's less than 12. Well, now all I have to do from here is solve, right? I just had this idea, so I'm going to move -4 both sides. I get -9 and 8. So my number that I'm going to add to 4 and have it work out is somewhere between -9 and 8. But -9 and 8 are not included. Okay, because if I added 8 plus 4, I'd get 12. That's not right. And if I added -9 plus -5, or sorry, -9 plus 4, it would get me -5. Okay, this is the end of the notes for this section. If you have questions, ask them in the discussion, please. I'll see you in 1.6.